So this video is going to go over double replacement or displacement reactions. So I put some polys in this one just to show you how to balance with polys. So double replacement is basically just like a square dance where the partners switch. So you're going to always have a compound plus a compound, and these will always be ionic. And what you're going to see, remember metals are written first, we're going to always see the metals just switch places with one another. So we've got calcium phosphate compound and sodium nitrate compound. So you've got two compounds, so it's double replacement. And we're just going to see those two metals switch places. So on this side, it doesn't matter which metal you write first. It just matters what you partner it up with. I'm going to put sodium first. It doesn't matter. But what matters is sodium is not going to stay with nitrate. Sodium is now going to be with phosphate. Okay? And then plus calcium. Calcium was with phosphate, so calcium is now with nitrate. Okay, so double replacement, just switch those front guys is all I did. So let's look, this is a compound, so it has a charge. Calcium has a +2, phosphate polyatomic has a -3. Sodium is a +1, nitrate is a -1, sodium is a +1, phosphate is a -3. Calcium is a 2 positive, nitrate -1. So let's look and see if the charges changed for any of the elements or ions. So calcium was a 2+ ion, and over here is a 2+ ion. Phosphate is a 3- ion. Over here is a 3- ion. Sodium is a +1. Sodium stayed as a +1. Nitrate's a -1, stays a -1. Double replacements are never a redox. Out of all your 5 types, this is the only one that is not a redox. So this is not applicable, not applicable. We do not need to put anything in that. So you can put NA, or you can put dashes, or you can put X's, but just don't put any elements in there, okay? So not applicable if it's not a redox. There's nothing that's being oxidized or reduced. So I am going to swap drop because it is an ionic compound. So you're going to get Ca3PO4 2. I'm going to put a blank in front of that. And then you're going to get Na, and I'm going to go ahead and put parentheses and the 1. I'm doing that for balancing purposes to show you. In fact, I'm going to go ahead and put that 1 there too, as well, I should say. And so we're going to get Na3. I'm going to go ahead and put my parentheses and my 1. It's going to help you see something. And then I'm going to put Ca1NO3 2. All right, so if I go to list just elements, this thing's going to get big because oxygens are all over the blooming place. So if you recognize that you've got polys on one side and the same poly didn't break up, sometimes they do break up, but as long as they didn't break up, when I do my little list, I can list them as a poly. So that's not a poly, so I've got 3 of those. But this is a poly, PO4, and out of those PO4, there are 2 of them. And then I've got sodium. There's just 1 of them. And that's a poly that's also over there. So I'm going to keep nitrate together. And then I wrote that 1 there for emphasis. I just have 1 of those. And so they're appearing in different order on this side because it's double replacement. But I'm going to write them the same order so I can just look across. Some students will put them out of order, which I guess if you can keep track, it's okay. It drives me crazy. So let's count. There is 1 calcium. There is 1 phosphate. Over here there are 3 sodiums, and there are 2 nitrates. All right, so I've counted my atoms. I'm totally not balanced. I picked something to start with. I'm going to pick the calcium here to see if I can get the calcium to balance. So I'm going to go times 3 here. So now that means I need to put a 3 here. But can you see that 3 is also multiplying by the nitrate? It's really multiplying by that 2 on the other side, or I can just go times 3. So I don't need to mess with that individual stuff, the oxygens. It just makes it easier. So now I'm going to have a 6 total nitrates. Okay? because I put that 3 times that 2 in there. So I can just pick phosphate to start with. A lot of students like to just mess with the elements themselves. I'm going to go ahead and go with phosphate. So this is a 2 and this is a 1. So in order to balance that, I would need to multiply by 2 here. So now I need to go find its blank, which is up here. And I'm going to go, oh well, that fixed that guy, but now 2 is multiplying by sodium as well, which is now giving me sodium as a 6. So if I come over here, I need to multiply by 6. So I need to put a 6 up there. Now do you see that nitrate is also getting a 6? So now look, 3, 3, 2, 2, 6, 6, 6, 6. Balanced. So I didn't need to do anything in front of this compound, so that would be an understood 1. So there is double replacement and an example how to balance with polyatomic ions. See you on the combustion video.